my dear students. Welcome back to my channel. So, welcome back to Exam Enhancer Session 6. So, in today's session, I am discussing about periodic classification of elements. So, basically, periodic classification of elements in my examination minimum 4, maximum 5 marks. Minimum 4, maximum 5 marks ge 100% question ಕೇಳಿರ್ತಾರೆ. Okay. ಸೊ ಮಿನಿಮಮ್ 4 ಮಾರ್ಕ್ಸ್ ಮ್ಯಾಕ್ಸಿಮಮ್ 5 ಮಾರ್ಕ್ಸ್ಗೆ ಈ ಲೆಸನ್ ಅಲ್ಲಿ ಯಾವ ಒಂದು ಸೆಗ್ಮೆಂಟ್ ಇಂದ ಕ್ವೆಶ್ಚನ್ ಕೇಳ್ತಾರೆ ಅಂತ ಅನಲೈಸ್ ಮಾಡೋದು ಬಹಳನೇ ಸಿಂಪಲ್ ಆಗಿರುತ್ತೆ. ಸೊ ಒಂದು ಕ್ವೆಶ್ಚನ್ ಲಾ ಬೇಸಿಸ್ ಮೇಲೆ ಕೊಟ್ಟಿರ್ತಾರೆ ಅಂಡ್ ಒನ್ ಮೋರ್ ಕ್ವೆಶ್ಚನ್ ಇಸ್ ಡೆಫಿನೆಟ್ಲಿ ಬೇಸ್ಡ್ ಆನ್ ದ ಟ್ರೆಂಡ್ಸ್ ರಿಲೇಟೆಡ್ ಟು ಪೀರಿಯಾಡಿಕ್ ಟೇಬಲ್. ಓಕೆ ರೈಟ್. ಸೊ ಆಸ್ ನಾನು ನಿಮ್ಮ ಪ್ರತಿ ಕ್ಲಾಸಲ್ಲೂ ಕೂಡ ಹೇಳೋ ಹಾಗೆ SSLC ಮ್ಯಾಥಮ್ಯಾಟಿಕ್ಸ್. ಸೊ ಈ ಮ್ಯಾಥಮ್ಯಾಟಿಕ್ಸ್ ಅನ್ನ ನೀವು ಏನು ತುಂಬಾ ಈಸಿಯಾಗಿ ಕಲ್ತ್ಕೊಳ್ಬೇಕು ಅಂತಂದ್ರೆ, ಮ್ಯಾಥ್ಸ್ ಅಲ್ಲಿ ಒಳ್ಳೆ ಸ್ಕೋರ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ, ಸೊ DVS ಮ್ಯಾಥಮ್ಯಾಟಿಕ್ಸ್ ಒಂದು DVS ಮ್ಯಾಥ್ ಚಾನೆಲ್ ನ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ಯೂಟ್ಯೂಬ್ ನಲ್ಲಿ DVS ಮ್ಯಾಥ್ ಚಾನೆಲ್ ನಲ್ಲಿ ನೀವು ದೀಪಾ ಮೇಡಮ್ ಹೇಳ್ಕೊಡುವಂತ ಎಲ್ಲಾ ಎಕ್ಸಾಮ್ ಎಕ್ಸ್ಪ್ರೆಸ್ ಸೀರೀಸ್ ಅನ್ನ ಫಾಲೋ ಮಾಡ್ತಾ ಬಂದ್ರೆ ಡೆಫಿನೆಟ್ಲಿ ಮೇಡಮ್ ಕಾನ್ಸೆಪ್ಟ್ ವೈಸ್, ಚಾಪ್ಟರ್ ವೈಸ್, ನಿಮ್ಗೆ ಮಾರ್ಕ್ಸ್ ವೈಸ್ ಏನ್ ಟ್ರೈನ್ ಮಾಡ್ತಾ ಇದಾರೆ, ಮ್ಯಾಥ್ಸ್ ಅಲ್ಲಿ ನಿಮ್ಗೆ ಔಟ್ ಸ್ಕೋರ್ ಮಾಡಕ್ಕೆ ಈ ಒಂದು ಸೆಷನ್ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. ಓಕೆ. ಸೊ ಸೇಯಿಂಗ್ ಸೋ ಮಚ್, ಇವತ್ತಿನ ಕ್ಲಾಸ್ ಅನ್ನ ಕಂಟಿನ್ಯೂ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಪೀರಿಯಾಡಿಕ್ ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಆಫ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಲ್ಲಿ ಬರುವಂತ ಒಂದು ಎಲ್ಲಾ ಸೆಗ್ಮೆಂಟ್ಸ್ ನಾನು ನಿಮ್ಗೆ ತುಂಬಾ ಡಿಟೇಲ್ ಆಗಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೀನಿ. ಅಂಡ್ ಒನ್ ಮೋರ್ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ ಇಸ್, ಇಲ್ಲಿ ನಿಮ್ಗೆ ಫಸ್ಟ್ 20 ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ದ ಬೇಸಿಕ್ಸ್. ಸೊ ಫಸ್ಟ್ 20 ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನ ಕರೆಕ್ಟ್ ಆಗಿ ತಿಳ್ಕೊಳ್ಳಿ, so that you can answer for any of the questions given from this lesson. Okay. So good morning everyone. I welcome each and everyone who are present in today's live. Okay. So saying so much. So 4 to 5 marks ಗೆ ಈ ಲೆಸನ್ ಅಲ್ಲಿ ನೀವು ಏನೆಲ್ಲ ಕಲ್ತ್ಕೊಳ್ಬೇಕು ಅಂಡ್ ಯಾವ ರೀತಿ ಪ್ರಶ್ನೆಗಳನ್ನ ಕೇಳ್ತಾರೆ, ವಾಟ್ ಆರ್ ದ ಡಿಫರೆಂಟ್ ಕೈಂಡ್ಸ್ ಆಫ್ ಕ್ವೆಶ್ಚನ್ಸ್ ದಟ್ ಹ್ಯಾವ್ ಬೀನ್ ಆಸ್ಕ್ಡ್ ಫ್ರಮ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಲೆಸನ್. ಸೊ ಈ ಎಲ್ಲವನ್ನ ನಾನು ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಬರ್ತೀನಿ. ಸೊ ದಿಸ್ ಸೆಷನ್ ಇಸ್ ಮೆಂಟ್ ಫಾರ್ 4 to 5 marks. Okay, right. So good morning to everyone. Good morning Jeevan, good morning Satish, Prajwal, most of you are there. Okay, right. So Prajwal, before starting the session only you're asking a question. Okay, fine. Okay, I'll get back to you Prajwal. So now the thing is, let us understand, so why do we have to learn periodic classification? What is the need of periodic classification? So before that, first let us understand how many elements are there in the periodic table. See, when we look at the periodic table, there are 118 elements. So in the periodic table, how many elements are? There are 118 elements. So what is the need of classifying this 118 elements? It is very difficult, children. So we can't keep everything in the mind. Like, see, every element has a different property. Okay, we can't, it is not so easy for us to remember the properties of all the 118 elements. So to study these elements very easy, what are we doing? We are dividing these elements into few groups in such a way that, see, some of the elements which are belonging to the same group are kept in the one group, so that all those elements are having similar properties. Some of the elements which are belonging to same period, when we arrange, say for example, say if I keep some element A, B, C and D in one of the period, now these elements which are in the same period are having some similar property. So the main reason that why are we classifying the elements is because, see, when we classify the elements, we can easily remember the properties of those elements. Some of the elements which are belonging to same group are having similar property. Some of the elements which are present in the same period are also having similar property. Okay, we can't remember all the elements. So 118 elements are there, we can't remember. So to make ourselves easy to understand periodic table, ನಮಗೆ ಈಸಿಯಾಗಿ ಅರ್ಥ ಆಗಬೇಕು periodic table ಅಂತ ನಾವೇನ್ ಮಾಡ್ತಾ ಇದೀವಿ, we are classifying the elements. That is very important. Next, ಈ ಲೆಸನ್ ಅಲ್ಲಿ ನಿಮಗೆ ಎಕ್ಸಾಮ್ ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂ ನಲ್ಲಿ ಏನ್ ಬರುತ್ತೆ, ನೀವು ಎಕ್ಸಾಮ್ ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂ ನಲ್ಲಿ ಏನ್ ತಿಳ್ಕೊಳ್ಬೇಕು, I will give importance only for that particular concept first. ಈಗ ನಾವು ಎಕ್ಸಾಮ್ ಪಾಯಿಂಟ್ ಅಂತ ಹೇಳಿದಾಗ ಈ ಲೆಸನ್ ಇಂದ 4 laws ಇದೆ. All the 4 laws you have to completely understand and all the 4 laws, on what basis the chemists have represented those laws, adu nimge clear agi ನೀವು ತಿಳ್ಕೊಳ್ಬೇಕು. All these things are very important. Let me begin with the first thing. We are getting into Dobereiner triads law. The Dobereiner triad, the Dobereiner is actually a scientist. Okay, he arranged the elements which was there during his period in the increasing order of their atomic masses. Okay, what Dobereiner did, Dobereiner ಏನ್ ಮಾಡ್ದ, he arranged the elements in the increasing order of atomic masses. Remember children, atomic number ಅನ್ನೋ ಕಾನ್ಸೆಪ್ಟ್ Dobereiner period ಅಲ್ಲಿ ಇರಲಿಲ್ಲ. Okay, during the Dobereiner period, the only thing which was there was atomic mass. Atomic number ಅನ್ನೋ ಕಾನ್ಸೆಪ್ಟ್ ಇರಲಿಲ್ಲ. So that is the reason he arranged the elements based on the increasing order of atomic mass. Okay, so when he arranged the elements in the increasing order of atomic mass, he found something different. What was the thing that he found? See, let me show first the elements which are present in the Dobereiner periodic table. See, can I now I have some of the elements which is belonging to his table. You can see here there is some 9 elements here. See, when he arranged the elements in his periodic table in the increasing order of atomic mass, he found that the mass of the middle element was roughly the average of the atomic masses of other 2 elements. Which was those other 2 elements? The elements which is present in the same group, that is the first element and third element. The mass of the middle element was roughly the sum of the average of the other 2 elements. This was the thing that is found in this periodic table. But not all the elements was following the Dobereiner triad law in this periodic table. Only the 9 elements which I am showing here were following his law. Okay, very simple. See, ಇದಕ್ಕೆ ರಿಲೇಟೆಡ್ ಆಗಿರುವ ಪ್ರಶ್ನೆಯನ್ನ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ. ಕ್ಲಿಯರ್ ಆಯ್ತು ಅಲ್ವಾ? ಇದಕ್ಕೆ ರಿಲೇಟೆಡ್ ಆಗಿರುವಂತ ಪ್ರಶ್ನೆಯನ್ನ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ. ಇಟ್ಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಚಿಲ್ಡ್ರನ್. So this law is very important. I repeat, what is the Dobereiner triad law says? Dobereiner triad law says the atomic masses, see, the atomic mass of middle element of the triad was roughly the average of the atomic masses of other 2 elements. ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ. ಈಗ ಲಾಸ್ಟ್ ಒಂದು ಸ್ಯಾಂಪಲ್ ಪೇಪರ್ ನಾನು ಸಾಲ್ವ್ ಮಾಡಿದೆ. ಸ್ಯಾಂಪಲ್ ಪೇಪರ್ ಅಲ್ಲೂ ಕೂಡ ಕೇಳಿದ್ರು. ರೈಟ್, ಈ ರೀತಿ ಕೇಳ್ತಾರೆ. ಎಲಿಮೆಂಟ್, ಸಿ ದೇರ್ ಆರ್ ಎಲಿಮೆಂಟ್ಸ್ A, B, C with the atomic mass 23 and dash and 27 ಅಂತ ಕೇಳ್ತಾರೆ. ಸೇ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್. ಓಕೆ, so find out the atomic mass of the middle element according to Dobereiner triad law ಅಂತ ಕೇಳಿದಾಗ ನೀವೇನ್ ಮಾಡಬೇಕು? What do you do? Simply you will take this element A and element C, you will add this. That means you will add 23 plus 27 and you will divide by 2. So 23 plus 27 is how much? It will be 50. So you make 50 divided by 2. That time you will get 2 ones are 2 25s you will get. So 25 is now the mass of the middle element. So like this you want to identify. Okay, like this you want to identify. Okay, so they will ask in the examination, children. Okay, yeah, I think you understood. So based on this law they will ask in the examination, they will ask you a question. So let us now go for the next. Okay, see, now there are few elements which is belonging to his table. See, now I have taken calcium, strontium and barium. This is calcium, strontium and barium. See, calcium and strontium, the atomic mass of calcium is 40 and the strontium is 137. When we add this and divide by 2, we get the mass of the middle element, that is the strontium. So remember, in the examination they may ask you that why are why in the Dobereiner triad law all the elements were not following his law? Because his law is saying that atomic masses of middle element is roughly the average of atomic masses of other 2 elements, and these average atomic masses of middle element could not be seen with other elements which was present in his periodic table. ಇದು ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು, ಕ್ಲಿಯರ್ ಆಗಿ ಗೊತ್ತಿರಬೇಕು. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಮಿಡಲ್ ಎಲಿಮೆಂಟ್ ಮಾಸ್ ನಾವ್ ಏನ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತಾ ಇದೀವಿ, ಇದು ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಗೂ ಅಪ್ಲಿಕೇಬಲ್ ಆಗ್ತಿರ್ಲಿಲ್ಲ ಅಂತ ಕ್ಲಿಯರ್ ಆಗಿ ಗೊತ್ತಿರಬೇಕು. ಓಕೆ, right? So now, so let's go for next, children. See, only the law of Dobereiner triad was applicable for 9 elements. That means there were only 3 triads. Only 3 triads were there. Okay, not more than 3 triads. And in ನೆನಪಿರಲಿ ನಿಮಗೆ 3 triads ಅಲ್ಲಿ ಯಾವ ಎಲಿಮೆಂಟ್ ಇದೆ ಅಂತ. Lithium, sodium, potassium, calcium, strontium, barium, chlorine, bromine, iodine. So these are the 9 elements which were, used, which was actually present in the Dobereiner triad law. Clear ಆಯ್ತು ಅಲ್ವಾ ಚಿಲ್ಡ್ರನ್? ಐ ಥಿಂಕ್ ನಿಮ್ಗೆ ಏನು ಡೌಟ್ಸ್ ಇಲ್ಲ ಅನ್ಕೋತೀನಿ. ಡೌಟ್ಸ್ ಇಲ್ಲ ಅಂದ್ರೆ ಚಾಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ನೋ ಮ್ಯಾಮ್ ಆರ್ ಎಸ್ ಏನಾದ್ರೂ ಒಂದನ್ನ ಮೆನ್ಷನ್ ಮಾಡಿ ವಿ ಕ್ಯಾನ್ ಗೋ ಫಾರ್ ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್. Okay, I think you clearly understood. Yes, let's go for next concept, children. Let's go for next concept. Very important. I repeat once again, these concepts are very important. ತುಂಬಾ ಸಿಂಪಲ್ ಆಗಿದೆ ಕಣೋ. ಏನ್ ಹೇಳ್ತಾ ಇದಾರೆ ಅಂತಂದ್ರೆ ಡಾಬರಿನರ್ ಟ್ರಯಾಡ್ ಲಾ ಏನ್ ಹೇಳ್ತಾ ಇದೆ ಅಂತ ಕೇಳ್ತಾರೆ. ಡಾಬರಿನರ್ ಟ್ರಯಾಡ್ ಲಾ ಏನ್ ಹೇಳ್ತಾ ಇದೆ? ದ ಅಟಾಮಿಕ್ ಮಾಸ್ ಆಫ್ ಮಿಡಲ್ ಎಲಿಮೆಂಟ್ ಮಾಸ್ ಏನಾಗಿದೆ? ಇಟ್ ಈಸ್ ದ ಸಮ್ ಆಫ್ ದ ಆವರೇಜ್ ಆಫ್ ದ ಮಾಸಸ್ ಆಫ್ ಅದರ್ 2 ಎಲಿಮೆಂಟ್ಸ್. ಅಂದ್ರೆ ಇದ್ರದ್ದು ಮಾಸ್ ನಿಮ್ಗೆ ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ ನೀವೇನ್ ಮಾಡ್ಬೇಕು? ಫಸ್ಟ್ ಅಂಡ್ ಲಾಸ್ಟ್ ಎಲಿಮೆಂಟ್ ನ ಮಾಸ್ ನ ಆಡ್ ಮಾಡ್ಬೇಕು. ಯು ಹ್ಯಾವ್ ಟು ಆಡ್ ದೋಸ್ 2 ಎಲಿಮೆಂಟ್ಸ್ and divide by 2, you will get the mass of middle element. That's all. Very simple. Okay. So Prajwal, you are having a question that like, why do we use silver bromine and silver chlorine in black and white photography? Basically, you know that the silver chloride, it can easily get decomposed. The silver chloride or silver bromide, they are having the property of decomposition. They can easily undergo decomposition when basically they are exposed to sunlight. Okay, so that is why they are used in the photography. Basically, I can tell them they are photosensitive compounds. So as they are photosensitive compounds, so they are undergoing decomposition, and they basically does, the disintegration of light. When they does disintegration of light, what basically happen is, we can easily get the thin films of photography. That is why they are used. Okay, so basically it's a wide concept. In examination, they ask you means you have to write that as they have the ability to undergo decomposition, hence they are used ಅಂತ ಬರಿಬೇಕಾಗತ್ತೆ. ಆಯ್ತು ಅಲ್ವಾ? ಸೊ ನೋಡಿ, next let us go for Newland's law of octaves. So Newland's law of octaves ಏನ್ ಹೇಳುತ್ತೆ? The Newland's law of octaves ಹೇಳುತ್ತೆ that actually during the Newland period, okay, there were only 56 elements which were there. So what Newland did was, what were the elements which were there during his period? He arranged all the elements in his periodic table. Okay, all the 56 elements he has arranged based on the fundamental physical and their chemical properties. He arranged the elements based on the fundamental physical and chemical properties. That means 56 elements ಅನ್ನು ಏನ್ ಮಾಡ್ದ? He arranged based on their chemical properties, especially based on how the elements react with both oxygen as well as hydrogen. Okay, he arranged the elements based on how the elements are reacting with oxygen as well as hydrogen. So ಇಲ್ಲಿ ನಿಮಗೆ law ಕೇಳ್ತಾರೆ. Newland's law of octaves ನಲ್ಲಿ law ಕೇಳ್ತಾರೆ. ಏನ್ ಬರೀತೀರಾ law ನಲ್ಲಿ? See, the law says the properties of every 8th element is similar to that of first ಅಂತ ಬರಿಬೇಕು. ತುಂಬಾ important law. The properties, see, every 8th element has the property similar to that of first one. See, I'll show you how. So this is Newland's periodic table. See, you can see some of the elements are there. See, hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen. Now, if I take hydrogen as first element, see, lithium as second element, beryllium as third element, boron 4, carbon 5, nitrogen 6, oxygen 7, and I am taking fluorine as 8th element. The hydrogen and fluorine are having the similar properties. If you now consider lithium as first element, sodium will be eighth element. ನೋಡಿ ಈ ರೀತಿ ಹೋಗ್ತಾ ಬಂದ್ರೆ by the time you reach sodium it will be eighth element. Lithium and sodium are having similar property. Like that beryllium and magnesium are having similar property, because if you take beryllium as first element and if you come till the magnesium it will become eighth element. See, now every first element and eighth element are having the similar properties. Okay, so that is the main, the concept of Newland's periodic table. But this Newland periodic table, what was the law is there? No, this law was not applicable for all the elements which was present in this periodic table. That is why we have some limitation. So based on the limitation, they will ask the question in examination. Okay. So Prajwal, you are again having a question like, ma'am, can I write endothermic? Yes. Example, see, all the decompositions are exothermic alla endothermic. Okay. All the decomposition reactions are endothermic. You can clearly write in the examination. Okay. Right. See, usually exam alli ಈಗ ನ್ಯೂಲ್ಯಾಂಡ್ಸ್ ಪೀರಿಯಾಡಿಕ್ ಟೇಬಲ್ದು ಎಲಿಮೆಂಟ್ಸ್ ನ ಸಮ್ಟೈಮ್ಸ್ ಕೇಳ್ತಾರೆ. ಒಂದು ಸ್ಯಾಂಪಲ್ ಪೇಪರ್ ನಲ್ಲಿ ನಾನು ನಿಮಗೆ ಹೇಳಿದ್ದೀನಿ. ಓಕೆ, ನ್ಯೂಲ್ಯಾಂಡ್ ಪೀರಿಯಾಡಿಕ್ ಟೇಬಲ್ಗೆ ಬಂದ್ರೆ ಅಟ್ಲೀಸ್ಟ್ ನೀವು ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, ಫಸ್ಟ್ ಅಪ್ ಟು 20 ಎಲಿಮೆಂಟ್ಸ್ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. ಬಿಕಾಸ್ Newland periodic table nalli, not all the elements were following his law. It was only up to calcium that his law was applicable. Up to calcium. Okay, very simple children. Up to calcium the elements were following the Newland's law. Okay, now I think nimge law clear agide ankotini. You all understood what is Newland's octaves law. Newland's octa is nothing but 8 children. That is why this law is there. Okay, octa is nothing but 8. What Newland said, every 8th element has the property similar to that of first element anta helda. Every 8th element had the property similar to that of first element. But there are some limitations in his periodic table. What are the limitations? I'm going to tell you now. See, in the Newland periodic table, not all the elements present in his periodic table were following his law. That means the Newland's law was applicable only up to calcium. This is the first, the limitation. His law was applicable only up to calcium. And next, there were 56 elements in his period. Newland told that there are only 56 elements in the nature. No more elements will be discovered in the future anta helda. But that is wrong. Okay, now we have 118 elements, not only 56 elements. He told that there are only 56 elements in the nature. We can't, discover no further elements in the future anta heltane. But it is not like that. There are so many elements now in the nature. You can see that. So hence, his second thought was actually the limitation. Next, the third thing what he told was, see, in order to adjust elements in his periodic table, you can see that he adjusted cobalt and nickel in the same slot. This is the wrong order of arrangement. Okay, see, in one slot only one element should be there, but in order to adjust the elements in his periodic table, he adjusted cobalt and nickel. This is the third limitation. And the fourth limitation is, see, basically he only told the elements which are having the similar properties are arranged in the same group. Correct now? See, according to that, see, hydrogen, you can see, according to that, yeah, here. Let me show you. According to him, the cobalt, nickel and iron, these were having the similar property. If these elements are having similar property, ಏನಾಗಬೇಕಾಗಿತ್ತು, ಅದನ್ನ ಒಂದೇ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಅವನು ಅರೇಂಜ್ ಮಾಡಬೇಕಿತ್ತು. But he arranged cobalt and nickel away from the iron. So again, this is also a limitation. Okay, so that is very important, children. So no place for isotopes anta helbedi. No place for isotopes is the limitation of Mendeleev periodic table, not the Newland periodic table. Clear aaytu alva? So I think all the 4 limitations you all understood. No doubt, no children? You understood Newland's law of octave, and you also understood what are the limitations of Newland's law of octave. Yes. Okay. So 4 limitations, very important, children. So basically trends ಗೆ ತುಂಬಾ ಇಂಪಾರ್ಟೆನ್ಸ್ ಕೊಡಬೇಕು ನೀವು ಇಲ್ಲಿ, ಬಿಕಾಸ್ ಟ್ರೆಂಡ್ಸ್ ರಿಲೇಟೆಡ್ ಆಗಿ ಪ್ರಶ್ನೆಗಳನ್ನ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಕೇಳ್ತಾ ಬರ್ತಾರೆ. So you should give more importance for the trends. Okay, right. Let's go for next. See, I think that every one of you understood the limitations, 4 limitations. Okay, I repeat once again. See, his law was applicable only up to calcium, and he told only the 56 elements are there, and cobalt, nickel, and iron were having the similar properties. They were arranged far away, and in order to adjust the elements, he kept 2 elements in the same slot. These are the limitations. I think nimge clear ಆಗಿ ಅರ್ಥ ಆಗಿದೆ. Let's go for next. See, Mendeleev periodic table. The Mendeleev periodic table anta ಹೇಳಿದಾಗ, see, Mendeleev actually arranged the elements in the increasing order of the atom. Basically ಹೇಳ್ತೀವಿ ನಾವು, ಈ ಪಾಯಿಂಟ್ ನ ಹೋಲ್ಡ್ ಆನ್ ಮಾಡಿ ನಾನು ನಿಮ್ಗೆ ಆಕ್ಚುಯಲ್ ಆಗಿ ಆಗಿರುವಂತ ಕಾನ್ಸೆಪ್ಟ್ ಹೇಳ್ತೀನಿ. Actually, Mendel has arranged the elements based on similar properties at regular intervals. Basically, he arranged the elements with the chemical properties. That means he took all the elements which was there during his period. He took all the 63 elements and he reacted all the 63 elements with hydrogen as well as oxygen based on the chemical properties that he has received, like halides and oxides. He has received halides and oxides based on his properties that he received as halides and oxides. He arranged all the 63 elements. But yavaga ಇವನು 63 elements ಅನ್ನು ಕೂಡ arrange ಮಾಡ್ತಾನೆ, he found that automatically all the elements were actually seen in the increasing order of atomic masses. Okay, he actually did not arrange it based on the increasing order of atomic mass. He arranged it based on the chemical properties. Okay, but when he arranged it according to chemical property, elements were automatically arranged in the increasing order of atomic masses. Okay, so that is the one important thing that we all have to observe in this periodic table. So what does Mendeleev periodic law says? The properties of the elements are the periodic functions of their atomic masses. Very important law. Either modern periodic law or Mendeleev periodic law, frequently they will ask. Okay, the properties of the elements are the periodic functions of their atomic masses anta they will ask in the examination. They will ask the law. You have to write the law. Next, when we look at his periodic table, see, most of the students were asking, ma'am, how can we remember this periodic table? Basically, they don't ask the periodic table which is belonging to Mendeleev. See here how the elements are being arranged. I will show you. You can see there is hydrogen in this table. Hydrogen is there, lithium is there, sodium is there. You all can see this hydrogen when it is reacting with this, see this property of R2O. What is this showing? The H R2O is, let me show what is what this, let me tell what is this R2O. So this R2O, what you are looking at here is R andre, R may be any element. It may be hydrogen, it may be lithium, or maybe sodium. Okay, see, ಈ R ಜಾಗದಲ್ಲಿ H ಹಾಕಿ ಏನಾಗುತ್ತೆ, it will become H2O. You in the same place R you write Li, that is lithium, it will become Li2O. Same in the place of R, now you write Na, it becomes Na2O. That means the elements which are present in this group are having the properties of becoming this dioxide. That means if I write hydrogen, it will become water. If I write lithium, it will become lithium oxide. If I write sodium, it will become sodium oxide. These kind of properties are there. Okay, ಅರ್ಥ ಆಗ್ತಿದೆ ಅಲ್ವಾ? Say for example, if I take this period, let me now take this period. Okay, so there is oxygen. Okay, so if I write R and O3, so what is this R and O3? R and O3. R, if R is in the case of R, if I write O, what does it become? If I write O in this case, O will combine with O3 and it will become O4. O4. What is O4? O4 kuda ide. We have different atoms of oxygen. we have O4, O5. So what is O4 anta kelbodu. So O4 is an actually allotrope of oxygen. We say O4 as the name of O4 is oxozone. The oxozone. ಇದೆಲ್ಲ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳಲ್ಲ ನಿಮಗೆ, ಬಟ್ ನಿಮಗೆ ಗೊತ್ತಿರಲಿ ಅಂತ ಹೇಳ್ತಾ ಇದೀನಿ. ವಾಟ್ ಈಸ್ O4 ಅಂತ ನಿಮಗೆ ಕ್ವೆಶ್ಚನ್ ಬರ್ಬೋದು, ರೈಟ್? ಸಿ ಇನ್ ದ ಕೇಸ್ ಆಫ್, ಈಗ ಸೇ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಆರ್ ಜಾಗದಲ್ಲಿ ಎಸ್ ಹಾಕೋಣ, ಅವಾಗ ಏನಾಗುತ್ತೆ? SO3 ಆಗುತ್ತೆ. SO3 ಅಂದ್ರೆ ಏನು? ಸಲ್ಫರ್ ಟ್ರೈಆಕ್ಸೈಡ್. SO3 ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ? ಸಲ್ಫರ್ ಟ್ರೈಆಕ್ಸೈಡ್. ಅರ್ಥ ಆಗ್ತಿದೆ ಅಲ್ವಾ? ಸೊ ಬೇಸ್ಡ್ ಆನ್ ದೀಸ್ ಕೈಂಡ್ ಆಫ್ ಪ್ರಾಪರ್ಟಿ that is been shown by the elements were arranged in the periodic table. Clear ಆಯ್ತು ಅಲ್ವಾ? O3 is ozone, O4 is oxozone ಅಂತ ಹೇಳ್ತೀವಿ. ವಾಟ್ ಈಸ್ O4? O4 is oxozone ಅಂತ ಹೇಳ್ತೀವಿ. ಕ್ಲಿಯರ್ ಆಯ್ತು ಅನ್ಕೋತೀನಿ, ರೈಟ್? ಈ ರೀತಿ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ನಿಮ್ಗೆ ನೋಡಿ, ನಿಮ್ಗೆ ಏನಾದ್ರೂ ಒಂದ್ ವೇಳೆ ಪ್ರಶ್ನೆಯನ್ನ ಕೇಳಿದ್ರೆ ಇದನ್ನ ರಿಲೇಟೆಡ್ ಆಗಿ ಇಟ್ಕೊಂಡೇ ಕೇಳ್ತಾರೆ. ಇದನ್ನ ಕೊಡ್ತಾರೆ ನಿಮ್ಗೆ ಸಾಲ್ವ್ ಮಾಡಕ್ಕೆ. ಇದನ್ನ ಕೊಟ್ಟು ನಿಮ್ಗೆ ಒಂದು ಎಲಿಮೆಂಟ್ ಕೊಡ್ತಾರೆ. ಓಕೆ, ಇಟ್ ಮೇ ಬಿ ಎಲಿಮೆಂಟ್ A, B, C, ವಾಟ್ ಎವರ್ ಇಟ್ ಇಸ್. ಓಕೆ, ಸೊ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ R2O3 ಅಂತ ಕೊಟ್ಬಿಟ್ಟು write the reaction of an element according to the Mendeleev periodic table. Element A with atomic number, say for example 13 ಅಂತ ಕೊಡ್ಬೋದು. ಅವಾಗ ಏನಾಗುತ್ತೆ? ಎಲಿಮೆಂಟ್ A with atomic number 13 ಏನಾಗಿದೆ? ಅಲ್ಯೂಮಿನಿಯಂ ಆಗಿದೆ. ಈ ಅಲ್ಯೂಮಿನಿಯಂ ಅನ್ನ ನೀವು R2O3 ಗೆ ಜಾಯಿನ್ ಮಾಡ್ತಿದೀನಿ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ? ಆರ್ ಜಾಗದಲ್ಲಿ ಅಲ್ಯೂಮಿನಿಯಂ ಹಾಕೊಳ್ಳಿ, ಅಷ್ಟೇನಾಗುತ್ತೆ? ಅದು Al2O3 ಆಗುತ್ತೆ, ಅಲ್ಯೂಮಿನಿಯಂ ಆಕ್ಸೈಡ್ ಆಗುತ್ತೆ, ಅಷ್ಟೇ. ವೆರಿ ಸಿಂಪಲ್. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಸೊ ಇದು ನಿಮ್ಗೆ ಕ್ಲಿಯರ್ ಆಗಿ ಗೊತ್ತಿರ್ಲಿ, ಓಕೆನಾ? ಇದು ನಿಮ್ಗೆ ಕ್ಲಿಯರ್ ಆಗಿ ಗೊತ್ತಿರ್ಲಿ. ಐ ಥಿಂಕ್ ನಿಮ್ಗೆ ಈ ಕಾನ್ಸೆಪ್ಟ್ ಅರ್ಥ ಆಗಿದೆ ಅನ್ಕೋತೀನಿ ಮೈ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್. ನಿಮ್ಗೆ ಕ್ಲಿಯರ್ ಆಗಿ ಅರ್ಥ ಆಗಿದೆ ಅನ್ಕೋತೀನಿ. ಓಕೆ, ರೈಟ್? ಯಾವ ರೀತಿ ಕ್ವಶನ್ ಕೇಳ್ತಾರೆ ಇಲ್ಲಿ ಅಂತ ನೀವು ಕೇಳ್ತಾ ಇದ್ದೀರಾ. ಬಟ್ ಅದೇ ನಾನು ಹೇಳ್ತಾ ಇದೀನಲ್ಲ, ನಿಮ್ಗೆ ನೋಡಿ ಈ ಫಾರ್ಮುಲಾನ ಕೊಡ್ತಾರೆ ಕ್ವಶನ್ ಕೇಳಿದ್ರೆ. ಈ ಫಾರ್ಮುಲಾನ ಕೊಟ್ಟು ನಿಮ್ಗೆ ಯಾವ್ದೋ ಎಲಿಮೆಂಟ್, ನಾನು ಹೇಳಿದ್ನಲ್ಲ ಅಲ್ಯೂಮಿನಿಯಂ. ಓಕೆ, ಅದೇ ರೀತಿ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಿಮ್ಗೆ ಇನ್ನೇನ್ ಕೊಡ್ಬೋದು? ಲೆಟ್ ಮಿ ಟೇಕ್ ಬೋರಾನ್ ಆರ್ ಲೆಟ್ ಮಿ ಟೇಕ್ ಬೆರಿಲಿಯಂ. ಓಕೆ, ಬೆರಿಲಿಯಂ ತಗೊಳ್ಳೋಣ. ಇನ್ ಎಲಿಮೆಂಟ್, ಓಕೆ, ಕ್ವಶನ್ ನೋಡಿ ಹಾಕ್ತೀನಿ ಇಲ್ಲಿ. an element with the atomic number 19, okay, is showing some kind of reaction, okay, R2O, okay. So write this element according to the Mendeleev periodic table ಅಂತ ಹೇಳಿದ್ರೆ ನೀವೇನ್ ಮಾಡ್ತೀರಾ? 19th ಎಲಿಮೆಂಟ್ ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀರಾ. 19th ಎಲಿಮೆಂಟ್ ಏನಾಗಿದೆ? ಪೊಟ್ಯಾಷಿಯಂ ಆಗಿದೆ. R2O ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ? ಆರ್ ಜಾಗದಲ್ಲಿ K ಹಾಕ್ತೀರಾ, ಇಟ್ ವಿಲ್ ಬಿಕಮ್ K2O. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಸೊ ವೆರಿ ಸಿಂಪಲ್. ಈಗ ನೀವು ಏನ್ ಬರಿಬೇಕು ಅಂತ ನಿಮ್ಗೆ ಅಲ್ಲೇ ಫಾರ್ಮುಲಾ ಕೊಟ್ಟಿರ್ತಾರೆ. ಸೊ ಅಲ್ಲೇ ಫಾರ್ಮುಲಾ ಕೊಡೋದ್ರಿಂದ ನೀವು ಯಾವುದೇ ರೀತಿ ಟೆನ್ಷನ್ ಮಾಡ್ಕೊಳ್ಳೋಂತ ಅಗತ್ಯ ಇಲ್ಲ. ಸೊ K2O ಅಂದ್ರೆ ಏನು? K2O ಅಂದ್ರೆ ಪೊಟ್ಯಾಷಿಯಂ ಆಕ್ಸೈಡ್. ಅರ್ಥ ಆಯ್ತು ಅಲ್ವಾ? ಎಸ್ ಸರ್. ಸೊ O4 ಬಗ್ಗೆ ನಿಮ್ಗೆ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಏನು ಕೇಳಲ್ಲ, ನಾನು ಜಸ್ಟ್ ನಿಮ್ಗೆ ಎಕ್ಸ್ಟ್ರಾ ಇನ್ಫಾರ್ಮೇಶನ್ ಹೇಳ್ದೆ. O4 ಅಂದ್ರೆ ಏನು ಅಂತ ಹೇಳ್ದೆ. ಸೊ O4 ಅಂದ್ರೆ ನಾನು ನಿಮ್ಗೆ ಹೇಳ್ದಂಗೆ ಆಕ್ಸೋಝೋನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಆಕ್ಚುಲಿ 4 atoms ಆಫ್ ಆಕ್ಸಿಜನ್ ಇದು. ಸೊ ಆಕ್ಚುಲಿ ಈ O4 ಅನ್ನೋದನ್ನ ನಾವು ಬೇಸಿಕಲಿ ಏನ್ ನೋಡ್ತೀವಿ ಅಂದ್ರೆ ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್ ಅಲ್ಲಿ ನೋಡ್ತೀವಿ, 4 atoms ಆಫ್ ಆಕ್ಸಿಜನ್. ಓಕೆನಾ? ಬೇಸಿಕಲಿ ದಿಸ್ ಇಸ್ ಸ್ಲೈಟ್ಲಿ ಡೇಂಜರಸ್, ಇಟ್ ಇಸ್ ಹಾರ್ಮ್ಫುಲ್ ಅಂತಾನೆ ಹೇಳ್ಬೋದು. ಕ್ಲಿಯರ್ ಆಯ್ತು ಅನ್ಕೋತೀನಿ, ರೈಟ್? ನೆಕ್ಸ್ಟ್ ನೋಡಿ, ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ ವಾಟ್ ಆರ್ ದ ಅಡ್ವಾಂಟೇಜಸ್ ಆರ್ ಮೆರಿಟ್ಸ್ ಅಂತ ಕೇಳ್ತಾರೆ. ಅಡ್ವಾಂಟೇಜಸ್ ಆರ್ ಮೆರಿಟ್ಸ್. ವಾಟ್ ಆರ್ ದ ಮೆರಿಟ್ಸ್ ಆಫ್ ಮೆಂಡೆಲೀವ್ ಪೀರಿಯಾಡಿಕ್ ಟೇಬಲ್? ವಾಟ್ ಆರ್ ದ ಮೆರಿಟ್ಸ್ ಅಂದ್ರೆ ಮೆಂಡೆಲೀವ್ ಏನೇನೆಲ್ಲ ಅಚೀವ್ ಮಾಡಿದಾನೆ, that is called as merit. Okay, so some gaps were left in the Mendeleev periodic table for the undiscovered elements, but Mendeleev did not think these gaps are defects. Anna idna defect anta tilililla. Rather, he has found out the properties of the elements which were discovered in the future, like gallium, scandium and germanium. Gallium, scandium, germanium ಅಂತ ಫ್ಯೂಚರ್ ಅಲ್ಲಿ ಎಲಿಮೆಂಟ್ಸ್ ನ ಡಿಸ್ಕವರ್ ಮಾಡಬಹುದು. ಅಂತ ಒಂದು ಎಲಿಮೆಂಟ್ಸ್ ನ ಪ್ರಾಪರ್ಟೀಸ್ ನಾವು ಏನ್ ಮಾಡ್ದ? ಪ್ರಿಡಿಕ್ಟ್ ಮಾಡ್ದ. So some gaps were left for the undiscovered elements like gallium, scandium, and germanium, and he predicted the properties of those elements. Okay, next. He also predicted the properties of the elements on the basis of their positions in the periodic table. Okay, so where the elements are present, based on the position of the elements, he predicted means he assumed, okay, the properties of those elements. And next, he accommodated the noble gases without disturbing the original arrangement. That is very, very important. Later what happened, noble gases were discovered like helium, argon, okay, helium, argon, neon, krypton, xenon, and radon. These are these are called as the noble gases. These noble gases were discovered later. So these elements were actually fit in this periodic table without, disturbing the elements which are already present in the some kind of arrangement. Okay na? Right. I think ಇದು ಕ್ಲಿಯರ್ ಆಯ್ತು ಅನ್ಕೋತೀನಿ. ರೈಟ್. ಸೊ ಬೇಸಿಕಲಿ ಈ ಟೇಬಲ್ ಇಂದ ಒಂದು ವೇಳೆ ಕೇಳಿದ್ರೆ ನಿಮ್ಗೆ 1 ಮಾರ್ಕ್ ಕೇಳ್ಬೋದು ಈ ಟೇಬಲ್ ಇಂದ ಅಷ್ಟೇ. 1 ಮಾರ್ಕ್ಗೆ ಆ ಎಲಿಮೆಂಟ್ ವಿತ್ ಫಾರ್ಮುಲಾನ ಕಂಬೈನ್ ಮಾಡಿ ಅಂತ ಕೇಳಬಹುದು. ಓಕೆ, ಅರ್ಥ ಆಯ್ತು ಅನ್ಕೋತೀನಿ. ಎಸ್. ಸೊ ವಿಲ್ ಗೋ ಫಾರ್ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ನೋಡಿ. ಸೊ ನೆಕ್ಸ್ಟ್ ನಿಮ್ಗೆ ಏನ್ ಪ್ರಶ್ನೆಯನ್ನ ಕೇಳ್ಬೋದು ಇಲ್ಲಿ ಅಂದ್ರೆ limitations of Mendeleev periodic table ಕೇಳ್ತಾನೆ. What are the limitations of Mendeleev periodic table? See, position of isotopes could not be explained. Already I told you, isotopes is nothing but same atomic number, different mass number. Say for example, carbon is having at mass of 12, carbon is also having mass of 13. If carbon is having 2 masses, carbon should get 2 different places, but Mendel could not give that kind of arrangement for the carbon. Mendeleev kodakagilla. So Mendeleev has given only one position for the carbon. So that was actually wrong. Okay. See, if there are different masses for carbon, the carbon should get different places. So could not give the position for the isotopes because the elements were arranged based on atomic masses in his periodic table. So he could not give the proper explanation for the elements which was present in this periodic table. It is very important. The position of isotope could not be explained. And no fixed position for hydrogen. Why? Because hydrogen was acting like both halogen as well as alkali earth metal. Hydrogen was behaving like both halogen and also like alkali earth metal. Hence, hydrogen was not having the fixed position. Clear ಆಯ್ತು ಅನ್ಕೋತೀನಿ. Next, there was 2 elements which was arranged in the wrong order. If you look at this periodic table, you can observe, here you can observe, see, cobalt which was having the greater atomic mass. Cobalt which was having the greater atomic mass was arranged before the nickel. 58.93 is there, next 58.71 is there. According to his periodic table, he only told elements should be arranged or elements are arranged in the increasing atomic mass. So now cobalt is having the greater mass, nickel is having the lesser mass. Nickel should come first, cobalt should come next. But in this periodic table, this was arranged in the wrong order. So this is the third, what I can say, the limitation. So these are the 3 limitations that you need to understand, children. So wrong order of atomic masses of some elements could not be explained. Cobalt was placed before the nickel. This was the wrong order of arrangement. This is the one thing that you all have to understand. Right, Alva? Right. So now let us enter to the modern periodic table. See, when we look at the modern periodic table, okay, see, let us first understand how are the elements arranged in the modern periodic table. See, in the modern periodic table, the elements were arranged based on the atomic number. Who has invented modern periodic table? The modern periodic table was invented by Henry Moseley. We also say this table as Henry Moseley's table. Okay, Henry Moseley, what he did was he arranged the elements based on the atomic number. Actually, why Henry Moseley did like that? There were some limitations in the Mendeleev periodic table. To remove the limitations which are present in the Mendeleev periodic table, the Henry Moseley has arranged the elements based on the atomic number. The isotopes and the concept problem ittu, right? Wrong order of arrangement of cobalt and nickel ittu, hydrogen ge proper position irlilla, idella reason agittu. To remove all these problems, Henry Moseley has arranged the elements based on the atomic number. Okay, when he arranged the elements based on the atomic number, all the problems which was there before in the whose table, the Mendeleev periodic table, was now completely cleared. Okay, so now the final table that we are finally using here is basically made by Henry Moseley, but the major contribution for the periodic table was being given by the Mendeleev only. Mendeleev only has arranged most of the elements, and the major contribution is given by the Mendeleev only. Okay, so I think whatever I have explained so far, you all understood, children. If you have any doubt, you can ask me related to these things. Okay, so in modern periodic table, I repeat once again, in modern periodic table, the elements were arranged based on the groups and also the periods. Groups and also the periods. Okay, there are 18 groups and there are 7 periods. ಇದಕ್ಕೆ related ಆಗಿ exam ಅಲ್ಲಿ ಪ್ರಶ್ನೆನ ಕೇಳ್ತಾರೆ. Based on this, the questions will be definitely asked in the examination. You should be ready to answer the questions asked in the examination related to modern periodic table. Okay, ನಿಮಗೆ ಇದು ಗೊತ್ತಿರಬೇಕು. The vertical columns are called as groups. Vertical columns ಏನು ನಾವು ನೋಡ್ತಾ ಇದೀವಿ ಈ ರೀತಿ ಇರುತ್ತೆ. These are called as vertical columns. These vertical columns are basically called as groups, and the horizontal rows, these are called as horizontal rows. Horizontal rows are called as periods. What do we call the horizontal rows? Horizontal rows are called as periods. Here aaytu alva? Right. There are 18 groups and also the 7 periods. You should know all these things. So what does modern periodic law say? The properties of the elements are the periodic functions of their atomic number anta helutte. I repeat, the properties of the elements are the periodic functions of their atomic number anta helutte. Clear aaytu ankotini? Tumbane important concept idu. Okay, right. Some of you are asking some questions like, ma'am, how could modern periodic table remove various problems from the Mendeleev periodic table? Simple, just now I told you, no. See, modern periodic table removed some problems of the Mendeleev periodic table. How? In modern periodic table, we arranged the elements based on the atomic number, correct na? When we arranged the elements based on the atomic number, isotopes got the proper position, correct? Because isotopes means having same atomic number. All the elements which are belonging to isotopes got the same place. Okay, and hydrogen, according to its atomic number position, it also got fixed position. And cobalt and nickel, so they were having the proper atomic number, and cobalt was placed after the nickel. Okay, that means in the modern periodic table, nickel is first and cobalt is next. Based on the atomic number, cobalt and nickel got the proper place. So like this, when we arranged elements based on their atomic number, isotopes got the proper place, hydrogen got the fixed position, and cobalt and nickel, according to the atomic number, they also were arranged in the modern periodic table. Okay, so this could be the one that is making to remove all the problems which were there in the Mendeleev periodic table. Here they don't ask any activity based question in the periodic table. The most important thing that you all have to remember here is they ask the question based on the trends. So they ask the question based on the trends. Okay, so in tomorrow's class I'll be teaching you about trends, children. So in tomorrow's class, tomorrow actually I don't have the class based on the timetable. So based on the timetable, I don't have class tomorrow, but I should teach you the trends. Trends are very important in the modern periodic table. This whole lesson only, trends is the one which I would like to give more importance and explain you. From trends, they will ask you definitely question. 3-mark question they will ask you from trends. Okay, fine. If I start explaining you trends, I need another 15 to 20 minutes. So today I will stop the class, children. I will try to organize the class tonight, okay, or tomorrow morning. If tomorrow morning, because tomorrow morning I have class at 6 o'clock in the academy also, I can't take the class in the morning, okay. So in the next class, I'll be teaching you about the trends, children. So trends in the periodic table. If you watch my next video, 100% you will get 3 marks. So already, whatever I thought from the morning, you got 2 marks from all the law-based questions. The next session is for 3 marks. I'm going to teach you about the trends. Okay. So if you find this video is useful, please like this video and share with all your friends, children. So one of you are asking a question, ma'am, cycloalkanes are saturated or unsaturated? See, how do you say cycloalkanes are saturated or unsaturated? Cycloalkanes. You can see there is ane. Ane is nothing but single bond. Single bond is nothing but saturated. So cycloalkanes are saturated. Okay? Clear now? Your doubt is clear, I think. Cycloalkanes are saturated. Ma'am, how questions be asked based on the table? They give table in as the questions and the ಕೇಳ್ತಾ. That's what. If you watch my next video, I will be solving some of the application questions related to trends by explaining the trends of the modern periodic table, so that you will be getting a clear idea. Okay. So thank you so much for being in the live, children. I think that you all got a clear idea about what has to be written based on the trends. So see you all in the next session with the trends belongs to modern periodic table.